How are complex expressions simplified in absolute value inequalities? Imagine trying to solve a puzzle where some pieces are hidden inside a box marked with absolute value symbols. It can seem tricky at first, but once you know the steps, it becomes much easier. When working with absolute value inequalities, the key is to make the problem simpler by isolating the absolute value part first. This means moving everything else away from it so that it stands alone on one side of the inequality. For example, if you have an expression like 7x plus 3 minus 2 less than or equal to 19, you start by adding 2 to both sides. Now, you have 7x plus 3 less than or equal to 21. Next, you rewrite the inequality without the absolute value bars by considering two cases. If the inequality involves less than or equal to, you turn it into a compound inequality. That means you write it as negative 21 less than or equal to 7x plus 3 less than or equal to 21. Then, you subtract 3 from all parts to isolate the term with the variable. This gives you negative 20 for less than or equal to 7x less than or equal to 18. Finally, you divide everything by 7 to solve for x, which results in negative 20 for divided by 7 less than or equal to x less than or equal to 18 divided by 7. When the inequality involves greater than or equal to, you split it into two separate inequalities. For example, expression greater than 5 becomes expression less than negative 5 or expression greater than 5. You then solve each inequality separately. If the inside of the absolute value is complex, involving coefficients, constants, or rational expressions, you carefully apply algebraic operations to both sides after removing the absolute value. This includes adding or subtracting terms, multiplying or dividing by constants, remembering to flip the inequality sign when multiplying or dividing by a negative number, and simplifying fractions. For expressions with addition or subtraction outside the absolute value, start by undoing those operations first. For instance, if you have 4x plus 2 minus 3 greater than 7, add 3 to both sides to get 4x plus 2 greater than 10. Then, split into two inequalities, for x plus 2 less than negative 10 or for x plus 2 greater than 10. Solve each one separately by subtracting 2 from both sides and then dividing by 4. When simplifying inside the absolute value, remember that the absolute value of a product equals the product of the absolute values. So, 4x equals 4 times the absolute value of x. Keep in mind that if the variable is inside the absolute value with an odd exponent or alone, it stays inside until you solve for it. To sum up, the main steps are: first, isolate the absolute value expression. Second, rewrite the inequality as either a compound inequality or two separate inequalities. Third, carefully perform algebraic operations to solve for the variable. And finally, simplify all expressions inside and outside the absolute value as much as possible. Following these steps makes solving complex absolute value inequalities straightforward and manageable, even when the expressions involved are complicated.